Hi, everyone, and welcome to today's webinar, Building and Monitoring Future-Proof Applications. My name is Star with Instana, and I'll be your moderator. Today, we're excited to have Adrian Colyer, venture partner at Accel and former CTO of SpringSource, VMware, and Pivotal, as well as Instana's CEO, Mirko Novakovic. Before I hand it over to our speakers, I have a few housekeeping items to cover regarding this webinar. First, today's webinar will be recorded and available on demand after the live session and will be sent to you via email, or you can always access it through Instana's website. Next, a huge thank you to all of you who registered. We pledge to donate $5 for every registration to the COVID-19 Relief Fund, and we're excited to share that we will be donating $1,325. Finally, we'd like to hear from you during today's presentation. If you have a question for our speaker, please feel free to send it through the Q&A box. We'll be answering questions at the end of the session, but if we don't get to your question today, we'll be sure to follow up afterward. So without any further ado, I'd like to kick things off by handing it over to Mirko.
Thank you, Star. And welcome everybody to this webinar. I'm excited and would say good morning, good afternoon, wherever you are, good evening. I'm Mirko, I'm co-founder and CEO of Instana. And I have the best job today. I basically have to listen to Adrian, and then I will be there for you for the Q&A session too. But I always enjoy listening to Adrian. He has been with a similar presentation to our kickoff, and we were very excited to hear his view. He's one of the smartest and brightest in our industry. I know him when we worked in the same company once at IBM, and he was working on Aspect J, and I was using it on WebSphere. So that's more than 20 years ago, I would say, a long time ago. And then I followed him closely when he went to Spring and did a lot of great things for the community. And I'm super excited. Today he works for Accel, and Accel is an investor in Instana. And I'm super excited to work with Adrian, and I'm super excited to listen to your presentation today, Adrian. And I therefore give it to you.
Brilliant. Thank you, Mirko. And extend my welcome to you all as well. Thank you so much for taking the time out to join us today. You know, the genesis of this talk, as Mirko said, is kind of interesting. So I want to talk a little bit today about sort of the way that we build applications has been changing, and of course that has a bunch of consequences in terms of the way that we manage them and we understand them. And the start of this talk was actually a meeting we held in London, a sort of breakfast briefing with a bunch of sort of customers from Instana and also from another Accel portfolio company called Humio, and with a bunch of senior people from sort of IT departments of organizations large and small, sort of talking about what their world was like and their estates and what was changing, etc. And sort of that feels like a different world, of course, when we all got together and did a briefing in the same place. And as Mirko said, I was very lucky to join the Instana team at their all hands in February of this year, which actually was again the last actual travel I did for business. So I say still in my memory very well, and had a great time with the Instana team. And kind of the presentation we're going to go through today is really sort of a distillation of some of those thoughts and ideas that come from those two places. And so what I really sort of wanted to take you through essentially was sort of a little look at sort of how we got to where we are. The world of application development has been changing. So sort of what are some of the big trends that we've been seeing over, let's say, the last sort of 5 years or so, and how they're impacting sort of our end user organizations. And based on that, we're going to spend a little bit of time looking at the implications of those changes for kind of how we operate, how we monitor, how we manage IT systems. And then sort of the first version of this talk was very much written kind of just around the turn of the decade, etc. And I thought it would be fun to finish with a little bit sort of looking at kind of, well, where might we be heading, kind of looking into the future a little bit of sort of what it might mean for forthcoming generations of monitoring and managing and sort of operating our IT systems. As Mirko pointed out when we were talking earlier, he felt like maybe I cheated him a little bit because I can do that by looking backwards and kind of taking that forward again. But we'll spend a little bit of time at the end of this just kind of looking at some things that I think sort of have been in the research for many decades actually, and still really speak to us today, and I'm sure will continue to speak to us in the future. So before we dive into all of that, I thought it'd be useful just to spend a few moments so that you know where I'm coming from and sort of my background. So if you know me at all, probably it's most likely you know me for one of these three things these days. So sort of, first of all, I'm what's called a venture partner with Accel, a venture capital firm, and as Mirko said, very happy to be an investor in Instana through that. Kind of, I guess the short version of this, with Accel, it's kind of my job to help find and build great technology companies born out of Europe and Israel. So that's kind of the essence of that role distilled. And then, as you heard, for many years, I was the CTO of a company called SpringSource, where we built the Spring framework, or of course, maybe now you know it as Spring Boot, and sort of the whole sort of generations of open source middleware around that time. And so I've really kind of grown up in and around enterprise application development and the supporting kind of systems and frameworks. So I sort of come from the enterprise app development and middleware side of the house. I also write a computer science research blog called The Morning Paper, which some of you may have come across. And sort of we'll return to that a little bit sort of towards the end of this talk, as I hinted at. But the basic idea there is this way, sort of three computer science research papers a week, kind of just where I'll select them, I summarize them, and then sort of share them. And that's been going for 5-6 years now. There's just over 1,000 paper write-ups on the blog, and we'll draw from some of those, as I said, through this talk. Okay, so if we are going to talk about sort of where we are and how we got here, and we're going to talk about APM then, and we should probably start with the the application space, which is, as you just kind of also heard, is sort of my comfort zone. And if I think about sort of some of the buzzwords that are maybe shaping application development over the last few years, you might think about phrases like cloud native, or sort of Kubernetes, or microservices, or maybe even serverless, etc. Perhaps you'll be relieved to hear that actually I don't really intend to talk about any of those in detail today. That they've sort of been done to death. They've been talked over to death. Instead, I sort of one of the things I love to do is let's try to see if we can take a step back together, and see if there's some kind of underlying theory that unites them that we can use to reason about the forces influencing what's happening and where it's going and some of the consequences of that. So we can at least have a shot at that during this talk. So I've been talking to sort of end user organizations on and off for several decades in various roles, and when I have those conversations over the years, they're really always the same two things that kind of come back at the high level in those organizations, that are like the high level objectives they're trying to strive to, beyond kind of like delivering a certain system for the business. And the two common themes that have always come out for me, well, one of them is obvious, like we want to cut costs, and that's kind of a seasonal thing, and something like, yeah, we'd like to reduce our costs. The other one is we want to go faster, because we want to improve our productivity. Now, sort of most of the time, I'm going to claim that cutting costs is more kind of a tactic rather than a strategy. Now, yes, you could have some kind of end-to-end design of a business model and the systems that go with it, designed to kind of disrupt a market with a radically different price offering. That's not really what most of the execs you talk to are talking about when they talk about cost cutting. They just want to reduce the cost of delivering on their estates and managing them. So really, it's far more interesting to talk about going faster, which is the huge pressure that's been on sort of all sorts of organizations, as we all know, kind of the pressure to compete, to do more, to go through the digital transformation, etc., as we hear about. So we're going to talk about sort of going faster. We might ask, what kind of faster do we care about? Clearly not kind of the going round in circles, that they're kind of the useless momentum, which actually you do see quite a bit of in some large organizations, but the kind of going faster maybe we really care about is how quickly can we deliver value? In other words, sort of you take this idea of kind of time to value, or so maybe sometimes called time to market, there's a huge amount of competitive pressure to go from idea or conception through to that concept, that idea is delivered live in production and bringing value to the company. You know, not only do you want to be first out there, but the quicker you get out there, the quicker you start the feedback loop. So the faster you learn, and the quicker you're able to move, the more times you go around that feedback loop, and gradually that's how you pull away from the competition. So yes, there's always these two themes, like I want to cut costs, I want to go faster. But when you really get into it, you know, sort of when Clement's right, many people would actually pay more in order to go faster. So that really is the high value, the high order bit for me. When we think about this sort of time to value idea, how fast can an organization deliver? Then sort of there's a sort of discipline called value stream mapping, and I picked a book here by sort of Martin and Osterling that goes into this, but there are many resources, which is the idea of just understanding how work flows through your organization. What are the various sort of stages in the processing of it? What are the handoffs, etc. Obviously, we could have touched on it, like the Phoenix Project, another great book that kind of interpolates these ideas. It's all about sort of understanding how work flows through a system, and this what happens between when you decided you want to do something and when it's live. Actually, when I'm sort of working with startups and doing diligence on investments, etc., that's also a question I love to spend some time on with young companies, and it's very revealing about their sort of future potential and productivity, etc. There's another recent book that Mick Kirstein recently wrote. Interesting tie-in, since Mirko mentioned it in the start. Mick Kirstein was also a member working on that Aspect J project back in the day. Anyway, he's recently written a great book called Project to Product, which expresses some of these value stream mapping and value flow ideas in a way that kind of the C-suite can understand. And so his message is kind of very simple at the high level. You know, stop thinking about delivering a project with a fixed end date, and instead start thinking about a continuous flow of value that this sort of never ends. It's more like managing a product. And so we're starting to develop these ideas around kind of the flow of value and the performance of an organization. Now, when you start analyzing the efficiency of a business or of an IT group in this way, there are two kind of fundamental aspects that come to my mind. Quickly, then I tend to use technology analogies for everything, be they business or organizational, etc. And so I would express them as throughput and latency, actually. And sort of by latency, I mean, it's what we naturally think of first. You know, how fast does one individual item get through the funnel? How long does it take to get end to end, as we've been talking about? But there's also throughput that matters. And by throughput here, it's just how much stuff can we deliver in unit time? So in other words, how much are we sort of delivering in parallel? And between the two of them, the throughput and latency dictates sort of how much we're actually able to release, you know, over time. Now, normally in computer science, of course, there's a trade-off between throughput and latency, and so your batch size is the lever that lets you manage that trade-off. In this arena, there's been some super interesting work over many years, and I hope, you know, this is many of you who've been exposed to this, maybe you've read it on the State of DevOps reports, you know, by Nicole Forsgren and Jez Humble, etc., looking at what's happening, what practices do people use, very wide survey, lots of statistical rigor underneath it. It's a great resource. And they studied, amongst many other things, the characteristics of the highest performing organizations. And they found that, you know, those organizations were doing multiple deploys per day. So they were moving faster, but also kind of counterintuitively, at least counterintuitively, sort of as of 5 years ago, but we're getting used to this idea. Moving faster actually led to higher quality, not lower quality. So, you know, sort of the old saying used to be sort of, you know, from Facebook, if you remember it, move fast and break things. But actually what we're coming to understand is, in a certain sense, move fast in order to fix things is actually the mantra. And of course, that's not just moving fast, you know, using all of our old processes and systems and approaches, but it's actually a set of changes we have to make in order to be able to move fast. And one of the reasons that sort of multiple deploys per day can work and can improve quality is because, you know, we're doing smaller units of change at each time. So we're catching problems earlier, they're easier to isolate, etc. and therefore it becomes easier to absorb a higher rate of change. Okay, so let's click here. Another way of thinking about delivering kind of more, this combination of throughput and latency maybe, is the idea of organizational scalability. So if we had a scalable organization, we could get more throughput, we could deliver more in parallel by adding more resource, and sort of maybe you're used to those nice sort of linear charts of computer system performance where you add more nodes and you're hoping for this sort of linear performance in the system. Well, ideally we'd like something like that in our organizations, right? We have more people and we get a nice linear increase in the output. And ideally we get that while still keeping the latency low for the delivery of any one feature. And when we come to analyze things like that, there's another great law called the Universal Scalability Law that tells us kind of what fundamentally drives systems as they scale and as they grow, and what limits the ultimate throughput that we're able to get. And that law tells us that there are really two key factors we need to pay attention to. And the phrase that they're called contention and cohesion. And contention is really all about there's a shared resource and we're competing for it. So if there was only one kind of delivery slot and everybody had to fight to get shoehorn their things into that one delivery slot, that would be contention. Cohesion is the cost of reaching agreement. So this is the cost of getting, in this case maybe in organizational sense, all the stakeholders to agree on this is the thing that we need to do. And when you sort of run the math and you play with this law, what becomes interesting is that sort of as you grow more and more and more, the cost of agreement, the cost of cohesion dominates contention. It's the major factor that ultimately limits the scalability of a system or the scalability of an organization. And so if we want to be changing things fast, we need these small units of change, as we've talked about. And we also need a low cost of agreement for each one of those units. It can't require kind of branching out to sort of 20 different people and getting them all to agree in multiple departments, etc. I see that actually as one of the pressures that's been moving us away from sort of monolithic architectures more towards microservices, both in a technical nature, but also, of course, in organizational structure. In other words, we're talking here really about Conway's law and about that symmetry between a technical architecture and an organizational design. And what's that doing, if you think about it, is breaking down these units of agreement, making it more modular such that you can move more freely within certain boundaries. And so one of the kind of general trends that I started to observe was, to a degree, and I think there are some limits on this that you wouldn't want to go past, but at a high level, things have basically been tending to get finer grained over time. And I think this is to do with these latency and throughput and cohesion ideas that we've been talking about. So you could look at, for example, the unit of compute, right? So we started with sort of like our physical box, then we've got virtual machines, then we had containers, and then now we've got sort of isolates, etc., getting finer and finer and finer grained. We could talk about sort of the unit of software delivery or packaging that goes from, from a monolith to, maybe an SOA kind of architecture to microservices. And now we're talking about functions as a service, which is kind of even finer grained in sort of a serverless world. Well, let's pick another dimension, release frequency, right? So, we used to do a big bang release once per year. It's hard to imagine, but it really did work like that. And then it was like, let's do one every 6 months. And that was pretty good, tough going. And then it was quarterly, then it was 2-week sprints. And then we do deliveries once a week, then daily. And as we've heard, like the highest performing organizations are releasing and delivering now multiple times per day. So on all these dimensions, if you keep taking kind of like these smaller and smaller discrete slices, then you end up kind of approximating a continuous ideal. And that's kind of why I put this kind of integration idea. It's a bit like calculus, right? And so you end up with this idea of a continuous delivery or a continuous flow of value as sort of what all these competitive pressures are funneling and forcing us towards. Okay. So then we might ask ourselves, like, if this is what we're aiming at, what all these forces are pointed in that direction, then what kills flow? Would be like, what's slowing us down? We talked about some of them, but if you studied some of the lean literature and Kanban, etc., one of the things you find is that wait times are really the things that kill your flow. And the biggest bottlenecks for wait times are handoffs between processing steps in this value stream, or in others, or between teams especially. One of the ways that you really recognize that, like staring you in the face inside many large organizations, is tickets waiting in service queues, for example. That would be a classic kind of handover between various kind of large departments in a bigger organization. And so all those people were there, and they had their functions because there were legitimately things that needed doing. But if things need to be done, they need to get done. But we want to avoid and minimize these long handoffs and wait times between teams. Then what can we do about that? So then another kind of big trend that we've all been seeing is sort of the force that comes to play here is this notion of, well, if we don't want to have handoffs across separate teams, we're somehow going to have to pull the responsibility for doing those tasks back into the original team and eliminate the handover. In the context of application development, we've kind of developed a buzzword, or a buzz phrase, I guess I should say, for that, that you may have come across, which is called shift left. And of course, I'm talking about as well the ideas of DevOps as we've come to know it, and then DevSecOps, and then many other things getting packaged in. This idea that instead of being a handover, we've got to pull it left and get it in an integrated team with kind of shared responsibility. And so when I think about shift left, some of the things that come to mind to me are this idea that we don't throw things over the wall anymore. So sort of if like an anti-pattern would be, hey, we do this whole development cycle and now we're ready to release. And at this point, we go to an external team who do a lengthy security audit and give us a go, no go. If you're trying to release multiple times per day, that's not a great process. And so we're looking at ways of bringing things, as I call it, into that delivery cycle.
Well, I think we lost Adrian for a second. Let's give him a second to join back in.
That's right. He shifted too far left. I saw that. Sure. Is there any questions so far I can maybe answer until Adrian is back? Yeah, when is Adrian back? That's a good question. I see the logo coming back, so looks like Adrian is back. Yeah, I will tell him to start over from the shift left.
Okay, can you hear me, everybody? Apologies for that. My primary computer I was using decided to have a complete meltdown, so I've joined another device, which thankfully was close to hand.
I wanted to ask you, Adrian, if this was a contention or cohesion problem.
I think it was contention because the fan's been going mad.
So I saw that people asked to start over from the shift left, if you can, to restart from there. Okay, thank you.
Yes. So let's just recap from here. So we talked about sort of what was killing flow, and sort of the biggest bottleneck in killing flow being the wait times between teams. So we're talking about sort of tickets, sort of sat waiting in service queues. One of the big tells in many organizations, and so that all those roles always come over there because things needed doing. But if we don't want to do handoffs between different teams, what do we do about that? Well, one of the things we can do is pull responsibility
into the same single team, and then avoid the kind of that cross-team handoff. And as I described, that kind of is obviously a buzz phrase that many of you will have come across. We call it the sort of the shift left idea, and it realizes itself in several different ways. And you'll recognize it, of course, as the phenomenon of DevOps, or then we've had DevSecOps, and then we've had various sort of words shoehorned into this kind of responsibility in a single team for multiple facets. So when I think about shift left, I think about a few things. So I think about sort of the idea that we don't throw things over the wall in quite the same way as one of the more fundamental things. So an example I would give is, you're working on a release, you want to do a deploy, you've got everything ready, maybe in the days gone past, we might package that up and we might hand over to a separate security team, for example, who would then go and sort of take a look, do their analysis and give you a go, no-go decision. But if, as we've heard, you want to deploy multiple times per day, that process probably isn't going to work very well. So we need to find ways to bring these kind of responsibilities, these things back into my delivery loop. Another thing it means that's kind of interesting to me is that essentially there aren't so many high priests anymore. So by the high priests, I mean like the people that have specialized ownership of a dedicated part of the platform and nobody else must touch it, and sort of you would pay your respects at the altar by entering your service ticket, and at some point you might be blessed with their service. But now, obviously, if you're thinking about pulling things back into the loop, about making shared responsibility into the team, then it means we're doing an approach that has to work for the many, not just for the few, which means for these regular application and service teams. So in other words, it also means we're going to have to do this in a language and in a way that the application/service team understands, i.e. from their perspective. And so sort of that changes a little bit of the emphasis when you take these left-shifted multi-responsibility teams and sort of start introducing them into an organization. Now, things get really kind of interesting. There we go. When you pull all of this together and you start looking like what are some of the consequences of this, and sort of start to get into what would this mean to manage, monitor, operate, such a complex application and estate and system. So the first question kind of seems natural to ask is, hey, we split the system into services and it's great, each service is now autonomous and it's way simpler and smaller and easier to understand. So where has all the complexity gone is one question that we might ask. And of course, there's some classic stuff about the essential complexity and accidental complexity. There's some kind of complexity that is of our own making, but there's also a bunch of complexity that's just inherent in the domain and can't be avoided. It's always going to be there. So where's this gone? And the answer is it's moved from being inside the services to the interactions between the services. And that can actually be a lot harder to see and manage in many senses than the complexity that was all in one place inside the monolith, for example. Another thing that kind of strikes me in this kind of world, this is a very, very ancient idea, stepping back into kind of a couple of millennia ago in philosophy, this notion of you can never step in the same river twice. Right? So it's this idea that sort of it's called the same river, but the water molecules, etc., are different. And well, if you're doing multiple deploys per day across many services, etc., that comprise an application and a system, you can never see the same system twice either. So every time you look at it, something's changed. We're under constant change of the system that we care about. And so one of the consequences you might start to think about of that is that static maps and sort of static topology assumptions just don't work anymore. You used to kind of walk into a large end user organization and literally there'd be a wall with kind of system diagrams and flowcharts on it, and that was how the system was, and it was it was stable enough in that architecture and that design to be printed out and be put on a wall and to be yellowed and fading but still be useful. Nowadays, you barely got time to print it before it was changed again. So we're living in this world of constant change. Another thing that's sort of really fascinating in these kind of systems is that when we've got many different parts and they're all changing, the interactions between these component parts can cause what's called emergent behaviors. So this is like sort of a behavior that wasn't explicitly encoded, but actually arises out of the interaction of all the different pieces. Now, of course, some of those emergent behaviors were desirable and hoped for, but some of them may be surprising and perhaps not so hoped for. For example, a denial of service kind of that's arising out of a bunch of restarts across the whole fleet. And so that would be kind of an emergent behavior, but not one that you really wanted. Another kind of phenomenon of these sorts of systems that's been talked and written about quite a lot is the notion of grey failure. And the idea of grey failure is it's a very, very difficult and tricky thing to get to grips with. So you start with this presumption that I've got enough moving pieces and enough going on, then failure is kind of normal. There's always some part of the system that's failing, that's not quite working, but we've built in lots and lots of mechanisms to recover from that, to keep going in the face of it, to mask it from the users, etc. But it has a bunch of consequences. So one of the things like, well, what does it mean for alerting systems, for example, if failure is normal? What kind of alerts are actually useful here? And the tricky thing is, we put lots and lots of effort into building parts of the system to cope with and to mask failure. Such it can be really hard even to ask the question, is everything okay? That becomes quite a tricky question to answer in the face of all this. And this is these grey failure states where on the surface everything looks okay, but underneath the system might be pedaling really, really, really hard to give that impression. And at some point we might find a threshold or a cliff edge that the system would go over and suddenly everything would not be okay. And determining sort of where we are in these kind of grey failure states and permanent failure states can be really tricky. Now there's one more sort of thing when I was kind of actually sort of pulling this all together and looking at some resources maybe to share with you at the end. I went to a place of looking at complex systems and the theory behind them, and I found another classic example of the kind of issues that we're talking about here, of why these modern systems are fundamentally different. This is a course you can take from the Santa Fe Institute called Introduction to Dynamical Systems and Chaos. And I put the link here, and it's quite interesting in the blurb. It's saying we're going to talk about sort of phase spaces and bifurcations and chaos and butterfly effects and all sorts of fun stuff in this course. But this phrase dynamical systems is actually it's a field of sort of applied mathematics, etc., that studies systems that change over time, precisely because all of these different emergent behaviors and things that happen are really counterintuitive, non-obvious, intricate, and kind of fascinating, unless you're the person on the hook to keep them running. So kind of like, very quickly here, you're like sort of, this idea of bifurcations that can happen is this one we were just talking about. It's the notion that some small change in a system parameter or an operating condition can lead, in some senses, to a very large and very noticeable change in the overall system behavior. And so there is sort of boundary and threshold conditions and no kind of linear cause and effect relationship necessarily. And then sort of even dynamical systems that are deterministic in every component can exhibit sort of random behavior at large. Sometimes this is called sensitive dependence. You might know it as the butterfly effect. The consequences of this is basically our ability to predict some phenomena is kind of limited. We can't always know exactly what's going to happen when we take a certain action. And as we'll see, we'll come back later, that has some implications for the kind of ways that we might manage and monitor systems. The idea that sort of that even though the overall system behavior might be disordered, it actually can exhibit stability in the large. And again, this is equated back to the idea we talk about grey failure, right? So the system could appear in the large to be stable and to be okay, but actually that's only a picture when you look at averages. So it can be that, so if you drop down a level and look into the details, some of those may not be stable, may not be predictable at all. And of course, as we've been talking about, there's this notion that complex behavior can emerge even from very, very simple rules. So the fact that you've got simple individual components doesn't necessarily mean you've got a simple resulting system behavior. And you can get sort of surprising complexity out of very small sort of initial part. So I guess the game of life would be a really simple version of that kind of idea. So so you can see actually that the world we've kind of moved towards, starting with these forces of actually we just want to deliver more, we want to start the feedback loop, we want to get the flow of value through my organization, is leading us to this place where we've now got a bunch of properties in the systems. Every step is quite logical, but that are really quite different to the very static kind of monolith that was the state of the art for kind of what we were managing, monitoring, for decades, really. So, as I've been kind of hinting at, what all of this means is that when it comes to APM, when it comes to managing, monitoring, operating, etc., the rules have basically changed. And sort of if you've been struggling to kind of keep on top of a bunch of applications using the tools and rules of the old world, you're probably finding they're breaking. And now maybe you've got a few extra ideas as to why that might be and some of the forces that are driving that. So what are some of these kind of changes that we might think about in this world? And the first thing that kind of came to my mind was actually this notion of sort of being instrument rated. And so this comes from, the analogy here is like if you want to learn to fly and get a private pilot's license, etc., then a pilot, as I understand it, will first learn to fly using what's called visual flight rules. And so this is the simple idea that the conditions are clear, you can look down, you can see the ground, and the pilot will navigate by kind of stable landmarks. So like you might see like this set of tall buildings, this river, etc., maybe this highway, but recognizable landmarks that you can look down and see them, know where you are, and navigate by it. But there comes a point in every pilot's training when, and certainly in poorer visibility conditions, it's a necessity that they have to do extra training to become what's called instrument rated. And this is so that they can safely fly a plane from their instruments, because they either can't see or they can't trust kind of the ground around them. And I thought, well, this is kind of very analogous to what we've been talking about with these IT systems. So it used to be possible to navigate an IT system using like the equivalent visual flight rules. That doesn't work anymore. With this fast rate of change, with great failures, with emergent behaviors, the pilots of applications and services essentially need to be instrument rated. In other words, I'm going to say that APM isn't like a nice to have, it's an absolute necessity for this world. So, as we were talking about, sort of the next thing here is that sort of the map of the terrain that we're flying over, that's not something that's statically defined up front anymore. Remember this idea, you never see the same system twice. So one of the things I assert you're absolutely going to need is kind of automatic and continually updated discovery of the topology and what's in the system and the lay of the land, essentially. And so, it's one of the things that Instana does, but I think this is an essential feature that you need in this new world. And then armed with an understanding of the terrain, we can begin to try and make sense of our systems. When we get into that space, I want to draw some analogy, something called the Cynefin framework, which essentially talks about the size of how we make sense of, and therefore how we manage different kinds of systems. And this is a guy called Dave Snowden who's been pioneering these ideas for many years. Obviously, the way that we interact with the system and we manage it actually changes as we move from an ordered world to an unordered world, and increasingly towards a chaotic world. And so if you start on what would be the bottom right here, in a kind of an ordered and obvious world, the world of the monolith world where we have best practices, then we can basically look at what's going on, so sense it, understand it, categorize it, oh, it's one of those, select the appropriate best practice, and off we go. As things start to get more complicated, then we have good practices, and the way that we operate there is still that we sense and understand what's happening in the world. We analyze what's going on. Now, I said just quick category. We've got to do a bit of thinking, but then we can select an appropriate response. But as we've been talking about, so we're increasingly moving towards this world of complex systems. So now we're sort of on the top left of this little quadrant here. The things that exhibit these emergent behaviors, the things where the linear relationship between cause and effect is probably broken. In this part of the world, there are emergent practices. But what's really interesting is the way you work with them changes. And so sort of beyond just like reading the current state of the system from a dashboard and deciding what to do. We might actually need to interact with the system, or what's called probing it in the context of this framework, and see how it responds in order to formulate a plan of action. And so sort of that tells us something about sort of a different kind of in the loop for our instruments and our APM, etc. You know, then we might go into the chaotic, there's a whole other sort of sense of practice, but what you see is in all of these different domains, the ability to sense the current state of the system is always important. Being able to do so with fine granularity and in near real time to enable these kind of new management practices for these complex and even chaotic systems starts to become kind of a table stakes for managing and operating sensibly in this new world. So another thing that I might observe here is that the nature of these complex and chaotic domains, sometimes unpredictable, or maybe retrospectively understandable emergent behaviors, is we don't always know what we're going to need to know. So if we're flying on instruments and our instruments aren't reporting the information we need, we could get confused very, very quickly. So the response, the logical response, it seems to me, to not knowing what will be important is to capture everything as much as possible. You know, again, this is something that sort of, you know, Instana is very good at, this super fine granularity of capture. The example I've chosen here is Humio, which is sort of a log management system that's also an Accel investment, so full disclaimer there. But this same principle of kind of, I like their phrase here, it's will log everything, answer anything, is kind of the level you want to get at. But we also, you know, sort of we talked about this mode where we have to probe to understand what's going on. And, you know, I don't want us to think that maybe that these modes are only for incident management, only when there's a problem, but it's actually also for normal operation. Like we actually need to probe these systems, as you saw, to understand how they behave, and then to reinforce the good behaviors that we observe, and maybe to shore up some of the bad behaviors. And so this leads to a whole other set of practices that are kicking around sort of in academia. A bunch of the thoughts in this area go around this term of resilience engineering. In industry, kind of a phrase that's been a little bit more popular is chaos engineering, which is really all about doing controlled experiments in your system or live systems to understand what's happening, how it responds, how it behaves. You can't do this kind of chaos engineering, this kind of resilience engineering, which, you know, the theories we're looking at are correct and what's necessary to build the level of robustness that we want now without a really great set of live feedback instruments. You know, that's just going to be a necessity in this kind of world. So, you know, taken collectively, you can see that there's some big changes sort of and implications for how we monitor and manage apps. And just for the last few moments, you know, with an eye on the time, leaving a little bit of time for Q&A, I want to talk a little bit about sort of where we're heading and some of maybe sort of what we can see in the past that is still perhaps in our future. And so, you know, sort of when I was thinking earlier this year about, you know, what are some of the big challenges that might still come up in this coming decade, you know, that I just rattled a few straight down. So I'm not saying these are the major, but there's things that immediately came to my mind, like how do we raise a level of abstraction? This is one of the things that sort of Grady Booch's phrase that's always stuck in my mind. You know, the whole history of computer science is one of ever-rising levels of abstraction. What does that mean for us now? There are some really interesting sort of design assumptions baked deep in our systems about the way hardware operates that are changing. I'm sure maybe where we've got some deep issues to wrestle with about the software supply chain and issues of trust, etc. in that, about how we develop, you know, sustainable open source software in communities. And, you know, so I guess going back to home, software is eating the world. Again, that old phrase you all know, the increasing automation that penetrates every part of our lives, every part of society. There are issues around kind of interpretability of the systems that we start to build, around bias and fairness in them. And, you know, a really interesting issue that crops up that I do want to zoom in a little bit, sort of, which I'll call here operating at the limits. In other words, if we use our best skill and wisdom and experience to build the most sophisticated system that we can, then how are we going to have the necessary skill to actually operate that thing? What does it mean like when we're kind of working at the limits of our abilities, which is where we normally do seem to be? And so kind of this is the kind of the cheat moment that I was alluding to, because it's kind of really hard to predict the future, as the famous saying goes. But there's one thing that maybe we can do here, which is to understand ideas, etc., that are likely to still be relevant whatever the future may bring. And this is I'm drawing something called the Lindy Effect here, and this is Lindy's restaurant, and the whole name, the Lindy Effect, comes from this delicatessen in New York, where comedians allegedly gathered kind of after shows to conduct kind of post-mortems on how it went and what was happening, etc. And this idea came out that eventually got spun into the notion that the future life expectancy of a non-perishable thing like a technology or an idea is proportional to its current age. In other words, the longer it's been around, the longer we've been talking about it, the more likely it is to still be relevant in the future for an equal amount of time. So we can find a few things that have still been relevant for 10 years or more previously and still seem to be. It's likely they'll still be sort of with us in 10 years' time. And so with that, I dove into the treasure trove of the morning paper, and I picked a few things that I looked at it in that environment. Starting with a real classic called Ironies of Automation, a fabulous paper by Lisanne Bainbridge, which is 1983. So this definitely qualifies for been around long enough that it's likely to be around a good while yet. And the central idea here is this question of the more we automate, so it seems ironic, hence the irony, is that the more we actually are dependent on the human operator, in the sense that increasingly the operators are only asked to take over in the circumstances that we weren't a priori able to predict, and hence needs to be very highly skilled to manage those situations. But because they're not day-to-day operating, because we've automated it, those very skills are atrophying. And so sort of how do we deal with this kind of need for a highly skilled operator in a highly automated world, and the fact that we actually become more and more dependent on those people and enabling them. So you'll find sort of lots of ideas in here. The notion like, do we need to have alarms on alarms for when the operator isn't paying attention to them, etc. All being discussed there. But let's focus on this fundamental idea of kind of when we're operating at the limit, kind of that the human is actually the bottleneck. Then the second paper I want to draw your attention to is called 10 Challenges for Making Automation a Team Player in Joint Human Agent Activity. So this is about 16 years ago, this paper. You think this is something about sort of where we're going of sort of automated systems of not just kind of understanding where they're at, but also maybe taking actions in accordance with rules and policies, etc. Then the system actually becomes almost like a member of your team that's responsible for certain tasks. And this paper really goes through what's necessary for an agent, for an automated system to be a full and equal participant in such a world. Things like there needs to be mutual predictability, so you can understand what the system's likely to do, or the agent managing the system is likely to do, and actually it can understand what you're likely to do. Mutual directability, maintaining common ground is a key one here. So this idea that all of the collection of humans and agents, etc., that are working together to manage a system have a shared language and understanding of the environment. And so sort of that's where, Instana has this lovely character called Stan that kind of is an embodiment of kind of their systems, etc. So I like to think of sort of Stan as a member of your team, and this paper kind of tells you this is what it means for Stan to be a great team member, for example, and to think about that. They're kind of more recently, we might touch on sort of John Osborne's master's thesis from 2015, which actually is just a detailed study of one single incident, one outage at Etsy, but there's a whole master's thesis based on it. And yes, you get a description of the incident, but really this is an analysis of how people actually collaborate and work together in high pressure operational situations, with a really great related work section in this paper. You'll find discussion of things like judgment heuristics and collective patterns of reasoning, etc. And again, a great quote in this paper, like the greatest sources of success in automation-rich environments are perhaps ironically the adaptive capacities of human cognition and activity, which again means that we've got to, through this instrument sort of rating notion, we've got to feed those humans everything they need to operate in that way. And the final one I want to touch on is the Stellar report from 2017, which is actually a workshop putting together participants from multiple organizations describing sort of how they were operating their systems and sort of common outages, etc. And again, you'll find sort of lots of wisdom in this paper, but also many of the things that we've been talking about. So, for example, we found that in common in many of these outages, the conditions were initially being buffered by system mechanisms before kind of something tripped. As we were kind of in a grey failure state. That they find this notion of fundamental surprises. In other words, the system just did something that nobody could have predicted, and the techniques that people use to deal with that. Here's a diagram from that paper that I found kind of quite helpful. That talks about the ground truth kind of below the line, what's going on in our systems, what's actually happening, etc. We can't really know that. We can only really understand or have a view of the system based on what our representations for all those different systems are telling us. So from our deployment tools, from our APM tools, from our code generation tools, etc. So more than we realize, those representations are super, super key. The other thing that's really interesting about this is it sort of tells you that actually what you think of as your critical systems from an operational perspective is way, way broader than perhaps you'd initially realize. And one of the things that kind of quite interesting is the thing that many people are most scared about is what happens if my deployment system goes down. If that's down, basically you can't fix anything else, right? So then you kind of got to promise yourself, oh yeah, actually that's a critical system for me. I hadn't thought of it that way, but it really is. So the idea here is that you've got to make sense of the system, using above the line of representation. In other words, using what it is that our instruments tell us. And so, with a little bit of an eye on the time, you can sort of think, well, we don't know what the future is going to hold, but we kind of can see that there are two things that are super, super important here, which is sort of the role of APM as a sense-making instrument. And, you saw in that sort of Cynefin framework analysis of all these different kind of domains that sense making is kind of central to everything, and and many things sort of begin with that. And then the increasing role as we get sort of more automation, more integration, more policy management of sort of having these agents, or Stan, if we're going to run it as a team player, being part of your system. And if you read those kind of 10 challenges, you'll see that yes, we've made some progress, but we've still got ways to go in kind of bringing that to full reality. So we've actually spent quite a bit of time, so I should have left more time for questions. So I'm going to sort of pause a little bit there and say sort of thank you huge amount for your patience. Sorry for the glitch. I want to just flip to this one slide that I'll leave you with while the Q&A is going on, which are sort of selected resources from some of the things that I've been talking about sort of through this talk here. If you Google any of these phrases, you'll find the resources quite quickly, and you can go take a look and sort of dig deeper if any of these things really kind of caught your interest and you want to go further. So I'm going to pause there. I haven't been able to keep an eye on the chat, but I'm sure sort of Mirko and Star have been, and if we have any, a couple of key questions, we're certainly very happy to take them now.
Great. We have a few minutes left for Q&A. So if you had something you wanted to ask, please go ahead and add it to the question box now. One question that did come in was, Avinji was asking about your vision for business IT analytics, since that could be a huge offering.
But sort of, yes, again, it's another thing that has been a massive, massive trend for us, obviously, over the last sort of 5, 10, maybe even sort of years, like this notion of a kind of a data-driven organization and sort of really getting strong insights on how the business is operating and all those fundamentals, which actually, the thing that I guess sort of most fascinates me about that has been the shift from sort of getting very batch, rearward-looking views of how the business is doing to this shift towards much more real-time and stream-based systems with a continuous type feedback loop of sort of, where am I now? What's the business doing right now? That shift I find sort of super interesting, because it gets quite deep into the technology and the architecture. But sort of, in general, and especially with some of these more sort of data science, machine learning models, etc., we can get quite sophisticated. We can get more real time. The other thing I'll touch on briefly in the answer to this that I also find really fascinating is this area of interpretability. So sort of, hey, you've produced a certain result, your analysts are telling you a certain thing, why? And can you explain that why to your business audience? So that has, I've seen in many, many systems, this notion of interpretability, which is discussed a lot in the machine learning space, essentially as well, is really, really key to getting real world end user adoption and buy-in to a new fancy system that you might roll out. And so anyway, those would be some of the kind of deeper, more forward-looking fun things I think about when sort of the future of IT analytics, et cetera, et cetera.
Yeah, I can also add one thing. For us, it's also, Adrian, you talked of the rising level of abstraction. And for us as a monitoring system, as everything is changing fast, business metrics can be an abstraction which are pretty stable. So if you are selling tickets, that's a very good abstraction to count the number of tickets you sold, for example, and then map the IT structure beneath, which is very unstable, to have a stable metric where you can basically see if something is working or not working. So this is something that drives us in the future, is looking for more abstractions, which we will probably find more on the business layer than on the, I would say, IT layer.
Yeah, that's a brilliant example, and it reminds me as well, we were talking earlier about those sort of properties of dynamical systems, and that they can have sort of a stable, a sufficiently high level, they can have a level of stability that's useful, and they can be very chaotic underneath. And so, yeah, some of the business metrics, obviously, as well as being super key, having them bubble up and giving you this more stable view, you're like, well, maybe it's an answer to great failure, right? So, hey, the system's down, does it matter? Well, are all the business metrics okay? And that's where these two things might kind of dovetail and be really powerful and important.
Yeah, we have one more question, which is that Nikolai asks, I see lots of overlaps with anti-fragile systems in your presentation. What is your take on such system paradigms?
Is that I guess some of the ways those are sort of slipped into my world is that I mentioned briefly Chaos IQ, which is another company that sort of I've been involved in that chaos engineering space, and so that sort of Russ Miles and Sylvan, and they've very much taken to heart these ideas of anti-fragility and what does it mean to kind of build a resilient anti-fragile system and understand that. And that's where some of these things I was discussing, like sort of the desire to probe the system and to see how it behaves and to learn from that and then reinforce, etc., and shore up those patterns. That's where some of that stuff comes in. But I do think these kind of resiliency, anti-fragile kind of properties are really important, that they're very hard to get right, that they require us to interact with the system, and they put a whole bunch of additional demands, but also importance on our tools for understanding what's going on in the world.
Yeah, I agree. I can add, I also invested in a company called Chaos Mesh, and they are in the chaos engineering space. And I really think that on a maturity model, this is really high on the maturity side. So you need to be very, very mature with your architecture microservice to really be able to build a resilience, anti-fragile system. So it's kind of very hard to build these things, but I think it's a very interesting topic. There's one more question. I think we have the time. Because we're building more little services and those are communicating over a message broker like Rabbit Kafka, does this help build a robust system?
So sort of high level, I'm going to say yes. So there are some properties about that are nice. So queues give you buffering and sort of temporal decoupling. They give you the ability to retry. They give you the ability to share load, etc. So there's a bunch of nice properties there. By having these individual services, you get sort of what we used to call a lot bulkheads. In other words, you get sort of failure and fault isolation. And so there are some attractive properties that this kind of sort of queuing interlaid services can give us. Also, like all of these things, they can introduce some complexities of their own. So you can end up with these, if you talk about the emergent behaviors from lots and lots of different parts interacting, you can end up with systems with a huge fan out if you're not careful, which is a scenario where it's like one user request, but on the back end, it's like 1,000 different things have to happen. And in that kind of world, you get other sorts of problems that are called tail effects. And there's a great paper called The Tail at Scale I'd recommend for looking into this, where, for example, if you're going to do 100 things, then actually just one of them needs to be a little bit slow and your latency starts to really go up, etc. And so you get other kinds of problems. So it's by no means a panacea, but there certainly are some architectural things to like about kind of that, a queue-based microservices architecture for sure.
Okay, great.
Good. Thanks again. There was, as always, you have the ability to structure very complex problems in a way that it's broken down to very simple and understandable paradigm. So I love it. Thanks again.
Pitch in the middle, and thank you so much for your time. I'm sure we'll find a way to get the slides and the references here out to you if you want to follow up. But yeah, thank you again for listening. It's my pleasure.
Thank you. Thank you guys so much. It looks like we're at the end of the time. So a link to view the on-demand webinar will be sent to you via email, or you can visit our website to access the recording. You can also check out our other upcoming webinars by visiting instana.com/webinars. Thank you all for joining us today, and we hope you have a great one.
Thank you, everybody. Bye-bye.